Here is a Past Labs X250 power amp. Today I'm going to show you how to upgrade the capacitors along the signal path. This is critical because the capacitor should be around 20-25 years now, and this is a relatively hot region, so the capacitor deteriorate sooner than they expected. But normally 20 years is already about lifetime of electrolytic capacitors. And on the other side, the capacitors used, let me point to you, for these electrolytic capacitors. So it's marked as 220 microfarad, 16 volts. And these are across the bias transistor, just to make sure there's no AC signal affect the bias. So it bypassed the AC. So these are originally, you can see they use electrolytic capacitor, polarized. And this is the Panasonic capacitor. It's a okay quality, but not the best. And if you look at the later Past Labs design, for instance, the X250.5 or X250.8, they start to use two capacitors in series each other. So basically, they make it more a bipolar kind of capacitor for this one, because that way you improve the linearity, particularly when the capacitor is inversely biased. So this is one thing we want to upgrade and replace, very critical. So that would definitely help improve the sound. And another critical capacitor, or actually two of them on each channel. So you can see at the input location, 1, 2. Again, these are the polarized Panasonic capacitor. They are rated, if you look at the board, they're rated 220 microfarad, 16 volts. But actually, if you check the capacitor, it actually uses 100 microfarad, 16 volt capacitor, the Panasonic capacitor. And these should also be replaced. As far as the value of these, I would say probably 100 microfarad is more than enough. And for me, I probably will be leaning towards half of that, meaning 47 microfarad with bipolar, again, the best quality. Because ideally, you want to use film capacitor here, but it's very hard to fit. You see, it's very tight spacing. The reason 47 might be better, even better than this 100, I think two things. One is these electrolytic capacitors, normally the lower the voltage, the lower the value of the capacitance, the lower the leakage. And also lower capacitance tend to perform better, more linearly at the high frequency range. So I would like to use slightly smaller capacitance along the signal path. The reason there are two of them, because one for each leg. So this is for XLR, right? You can imagine it's kind of plus and minus of the balance input. And if you look at the impedance of the input, this is rated like 11 kilo ohms single-ended or 22 kilo ohm differentially. If we only look at single-ended for this capacitor, you can imagine even 100 microfarad for 11 kilo ohm input impedance is quite high. So 47 microfarad capacitance should be sufficient, go all the way down to less than 1 hertz, the tuning frequency. So it's sufficient, and it will definitely improve the mid-range and high-range performance, imaging, sound quality, clarity, everything you can imagine. And as far as the type of capacitor I'm going to use, so this is the one. You see, this is a green color. It's the famous Nichicon Muse Bipolar. So BP stands for bipolar. And the product code is ES series. So if you search on DigiKey or Muse, you can search UES. So that's basically give you this. I got it from Muse. So you see, this one is 220 microfarad, 16 volts. This is the one I'm going to use to replace these ones across the bias resistor. It's larger, right? You can see it's much larger, but it should fit the position. There's sufficient room here to fit. So 4 of them. And then the signal path, as I mentioned earlier, I do have a 100 microfarad as well, but I plan to use the 47 microfarad. So that way you have better mid-range and high-range response. And you shouldn't lose on the low frequency, as I mentioned earlier. And size-wise, it's slightly larger diameter, similar height. So it should fit perfectly. Is this 47? 4 of them, replace them. So this is very much what I'm going to do at this time to upgrade the electrolytic capacitor along the signal path. This should significantly improve the sound quality. By the way, I already done the recap. If you look at my other YouTube video, I have recapped the main power decoupling capacitors, including the lower ones with Rubicon. And also I enlarged the parallel capacitors for the mid-range and the high frequency range decoupling. So from the original 220 microfarad to 1500. So it will be better for the mid-range particularly. So the original capacitance is a little lower. If you look at the later past lab amps, .5 or .8, they use the bigger ones, 2000 microfarad. So I'm using 1500 microfarad. So those are the things you want to do if you own one of these. They sound superly good. I would say they, at least comparable, I would say sound better than the .5 if you do all these recaps and upgrade as I mentioned here. And if you fine tune the bias, right, this is the input board, adjust the offset and the bias on the 4-point. You do some balancing between plus and minus lags and between channels, you will get very, very good sound from this amplifier. And one little trick here is that in order to take out the top panel, so only 6 screws, so very straightforward. However, it's quite tight. So one thing you want to do is to loosen the screw on the back a little bit so that this plate can move a little bit and you can take out the top cover much easier. It's just a little trick here. So I'll continue with this replacement. I'll show you later on. Basically, you need to flip the amp on the sideway and remove the bottom plate so that it can expose this board from the bottom side. You can unsolder these capacitors and then solder the new ones on. In order to remove the bottom plate, you will need to remove these cables. These are relatively easy to remove. Just unscrew them. And also you want to remove the cable on the plug, the power plug. And then there's a power switch. Power switch, actually, you don't have to remove cable. You just unscrew it. And by the way, when you remove this cable, remember to take a picture so you know the which color and which wire to wear. So after you remove the two screws, you can pull this plug out and desolder. Again, take a picture, remember the color of the wires. After you remove those wires and the power plug, you can flip it up. And then you can see the 6 screws holding the bottom plate. Again, these two also need to be loosened a little bit, but you don't want to do it now, because if you do it now, this whole thing might not be stable, right, when you put it down. So leave that 2 screws tightened, so that might help to hold this bottom plate in place. Even so, when you remove those screws, be very careful, not let the bottom plate slip down. That might hurt things. After removing the bottom 6 screws, carefully flip it down, and while you use finger, hold down the bottom plate. Don't let it go free. And now you can loosen these 2 screws so that you can freely lift this up. Let me see. You should be able to. Yeah, see? You can lift it up. You can separate the bottom from this circuitry on the side so that you can work on the circuit on the back side. So again, I will move it up and then flip it on the side and remove the bottom plate so that I can work on the board. Once you lay it upside down, you can see the bottom circuitry. You can start to work on those capacitors, desolder and resolder the new one. The input capacitor on this side and the bias capacitors are here, here, and here, and here. So it'll be pretty easy to work with. Probably you also want to flip it on the sideways so you can see both sides, the component side as well as the circuit side. But whichever way works better for you. So all 8 capacitors are replaced with the Nichicon Muse ES series bipolar capacitors along the signal path, which is considered the best electrolytic capacitors. They are very much comparable to film capacitors based on lots of professional reviews. So by the way, input 2 of them for balance input on each leg, plus minus leg. So 2 of them. By the way, I use 47 microfarad. The original one was 100 microfarad. So it's slightly cut by half, but if you do the calculation for the input impedance, the low frequency response won't be affected. And by using the slightly smaller capacitance, you will have more linear performance at high frequency, as well as lower distortion. So the 4 capacitors across the bias transistor are also replaced with Muse capacitor with the same value. You can see the original ones are quite small compared with the new ones. They're both 220 microfarad, rated 16 volts, but the Muse capacitor is much higher quality. It's a bipolar, by the way. So a long signal path bipolar is preferred because there's no polarity differences when signal pass through the capacitor. So it's more linear, less distortion. 1, 2, 3, 4. So you see each channel, there are 2 of them. One is for the plus side, the other is for the minus side because it's kind of a differential drive. And then after you're done the replacement and reverse the process to assemble everything back. So again, you solder these plugs on and re-screw the cables as you took the picture, which wire to go where. And again, for the bottom one, you align and drop it down. And make sure when you tighten the bottom screws, tighten these 2 first so that you can flip it up without dropping the bottom plate. And then double check on everything before you connect the power and power it up. Once you power it up, you can roughly adjust the double check on the bias. So there's a plus bias, minus bias on each channel, and also double check on the offset. So this is absolute DC offset, and the inner one is for the differential offset. Make sure you can adjust within, I would say 10 millivolts or 20 millivolts should be sufficient. We just finished the recap for the signal paths for the past labs X250. So the next thing I'm going to do is to compare with the Luxman M900U, which I like very much. Again, the speakers we're going to use are the floor standards 3-way, the big one. So now we're playing Luxman.